Okay, so how are we going to calculate the volume of this thin-walled cylinder? How are we going to do that? Well, I think, to think about it in an intuitive way, we can think of this as the thin-walled cylinder, and if we brought that cylinder out, it would look like, this, kind of like a cup with no top or bottom. And maybe I should just draw in a little thickness so you can kind of see that there is thickness to the wall. Now, of course, in calculus we're going to take this to the infinitesimal, and this becomes infinitely thin, and this, that, and the other. But for right now, imagine that there's some thickness here. That thickness is in this axis. That thickness is our dy. Now, at some point, initially, we can think of it as being a real number that we could, like 0.01 or something like that. But obviously, we're going to take this to the limit, becoming infinitely thin. Great. Now we also have a height here like that. We still don't see exactly how are we going to get the volume of this weird little thing. What I'm going to suggest we do for thinking about it intuitively is imagine we were to cut this cup along the edge and unroll it. And then we have a more intuitive thing for calculating its volume. Now it becomes a sheet like this. This is exactly the same material as this. Here is our height, the width, and that is dy, and we'll call this height. And this now is a length, okay? But really, when you think about it, what it actually is a radius around this thing. Excuse me, not a radius, a circumference. It's a circumference. And if we know the radius is r, then we know that the circumference of this cup circumference is equal to 2 pi r. Okay, and that we know from geometry. It's just pi d or 2 pi r, whatever. And so this length is equal to a circumference, which is equal to 2 pi r. So now when we ask the question, what is the volume of this thin-walled cylinder? It's going to be 2 pi radius times height times dy. And if we integrate this, we're going to get the volume of the entire projectile, this entire solid of rotation, because what we're going to do is we're going to take every possible thin wall cylinder, from different parts. So we're going to integrate over this range in y from 0 to, if we make this endpoint here 4 on the x-axis as we did before, then the square root of 4 is 2, like that. So we want to integrate over this range. But recall that our original equation that we were given was given in terms of x. We want to re-express it in terms of y because we're going to be integrating over this range. So we now say y is equal to square root of x, square both sides, and we get y squared equals x. Okay, so that this will be the equation we're going to be using. All right, I see that, but exactly how are we going to do this? How are we coming up with the radius and the height for this particular function using this equation?